So last time we talked about factoring out a greatest common factor and factoring by grouping. So today we're going to go through that again, doing some of these practice here. On this one, I'll leave pardon me, the rest of them for you for practice as well. But then we're going to get into more factoring start factoring three-termed polynomials. All right, so let's look at this to factor out. Let's talk about factoring out our greatest common factor here. So let's look at these first couple. So remember, for greatest common factor, we look at the numbers to figure out the biggest number that divides all of them, so we can pull that out. And we also look at the variable part. So if I look at the numbers, if I look at the 2 and I look at the 14, what's the biggest numbers we can pull out there? A 2, right? Do they have any variable piece in common? No, so I can't pull out any variable at all, right? When we pull out the 2, what are we left with in the first term? X squared, right? Because the 2 came out. When we pull out the 2 out of the 14, what are we left with? 7. Oops, I forgot my squared. And that's as good as we can get for this particular problem. Literally, the only thing we can pull out of there is a 2. Let's look at the next one. We'll talk about this one together. Then I'll let you work on the next two for a minute, and we'll chat about it. Let's look at the next one. In this one, we've got an 8x squared and a 12x. Looking at just the 8 and the 12, and sometimes you might want your calculator to see if you have things in common to divide. Some of the numbers get bigger. Okay, but we have an 8 and 12. What's the biggest thing that divides both of them? 4, because 4 goes into 8, 4 goes into 12, all right? Looking at your x pieces now, what do they have in common? 1x, right? This one has got 2 x's, that one's got 1x, so they have 1x in common, so we'll pull that one out as well, all right? So remember, when we're factoring, we're trying to reverse the distribution process. That's the whole point, right? We're trying to reverse multiplication. So I pulled out the 4, I pulled out the x. When I pull out the 4, what does that leave with the 8? How many times does the 4 go into the 8? 2. I pulled out one of the x's, so how many are left over in this one? Just one of them, right? So we get 2x on that one. For the next one, when we pull out the 4 out of the 12, what are we left with? A 3. When we pull out 1x from 1x, we're left with just 1, right? The x got pulled out. So again, this is factoring out the greatest common factor out of those. So work out the next two, and then we'll chat about a couple more that are a little bit bigger, and we'll make sure we do the factoring by grouping before going on to the next one. So work on C and D. Ready to chat about it? Baby. I said, we're ready to chat about it? Yeah. Ready? Okay. All right. Let's look at these two. Let's look at letter C here. I look first at the numbers. What do the 6 and the 10 have in common? A 2. Okay. So we pull out a 2. Is there a variable piece that they both have in common? No. Okay. So the only thing we can pull out is a 2. What does that leave us with? 3x squared in the first one. Good, because we pulled out the 2. So basically when we're pulling it out, we're dividing by it, right? Divide the 6 by the 2, we're left over with a 3. We couldn't pull out any x's at all, so the x squared stays there. What about in the second piece? 5. Yeah, everybody minus 5? Good. And again, when you think about pulling out that common factor, really we're just thinking about dividing those things. That's why, again, calculator, if you're having trouble seeing what divides them, calculator can help. That one okay? Yeah. How about part D? Looking at the numbers again first. We got a 24 and a 40. Yeah, 8 works nicely, right? Because 8 goes into 24 3 times. 8 goes into 40 5 times. Okay. How about the variable pieces? If I look now at just my x's, what can we pull out? An x. Good. Because there's 2 x's here. There's 1 x there. So they have 1 in common, right? So I can pull out 1. And the y's, they pull out a y. Good. Everybody okay with the greatest common factor? Okay. Once we pull that out, what are we left with in the first term? Good. Yeah, we take out the 8 out of the 24. We're left with a 3, right? Dividing the 24 by the 8. Pull out 1x. We're left with 1 still. Pull out the y. It's gone, right? What about the second piece? 5 for the 40 and then a y as well, right? Because again, for the second piece, we pulled out the x, so it's gone. We pulled out only one of the y's, so we're still left with a y. That okay? Happy with that? I'll leave these last ones here for practice for you. There's answers posted on Moodle as well, so if you practice and want to check your answers, they'll be there. But I want to make sure that we do another example here with grouping, and then we'll do an example where we're putting the two pieces together. Make sure that we've got, understand what we want to go through for our process with factoring before we add on new techniques. Okay. When we're doing grouping, the only time that you're going to apply grouping for factoring is if you've got a polynomial with 4 terms in it. Okay? If it doesn't have 4 terms in it, you don't need to worry about grouping. Okay? Only if it's got 4 terms are we going to worry about grouping at all. Okay? All right. So remember, for grouping, we want to look at the first 2 terms together and the second 2 terms together and see if we can pull out a greatest common factor. Just looking at the first 2 terms, what did they have in common? An a. Good. When we pull out the a, again, just out of the first 2 terms, what are you left with? C plus d, right? Because we pulled out the a, right? So it's no longer on the c and it's no longer on the d. Okay. Now remember, the whole point of factoring by grouping is that whatever you see in the parentheses here after you figured out this GCF, you want to see the same thing in parentheses in the second one as well. Okay? So I know that I'm looking, if it's going to work, it may not work, okay? But if it's going to work, I better see the same C plus D in parentheses on the second piece. Okay? Looking at those last 2 terms, what can you pull out? B. If you pull out B, what are you left with? C plus D, which is a good thing, right? Okay. So now, looking at this as a whole piece, that's in common in both of those 2 pieces, right? So we pull out the whole C plus D, if we remove the C plus D, what's left in the first term? Just an A, and then the second one, a B. The reason why, again, that we want to see that whole piece in the parentheses being the same is because now we're treating it like that whole chunk like it's the GCF and pulling out a GCF. Okay? Pulling it out in front. Let's look at letter C here, the one right below it. Okay, let's look at this one together. Then we'll do one where it's also got a GCF in it, and then we'll go on to some new stuff. All right, so again, factoring by grouping. Again, group the first two, group the second two, and look for GCF. Okay? Looking at just the first two terms, what do they have in common? Yeah, the P, right? The only thing they have in common is a P, right? Okay. Pull out the P. What are you left with? Yeah, 2W plus a V. I agree. So since we see 2W plus V in the first chunk, what do we want to see in the second chunk? 2 plus W plus V again, right? Better see that if we're going to be able to factor it, right? Okay. So looking at the second chunk, what's the GCF? There's a 5 and a Q, right? I got a 5 goes into the 5 and it goes into the 10, and then I've got a Q in both of them. What are we left with? A V in the first one and 2W in the second one, right? Are those two chunks now in the parentheses the same? They look a little bit different, but we can add in either order, right? 2W plus V is the same thing as V plus 2W, so that's the same thing. So what do we do with that now? What do we do with this whole thing and this whole thing? You can do the 2W plus V, and then what's it going to be multiplied by? The P plus 5Q. Good. So again, the whole goal of this factoring by grouping is to see the same group in both terms, so then you can factor out the group. Okay? That's the whole goal. So let's see if we can do an example where we put both of these together. Are there any questions about that one in particular? Okay. Let's see if we can do one where we have to factor out a GCF and factor out the grouping. There should be one in here somewhere. Maybe not. Maybe not. These are all factoring by grouping. Let's do one more like with a factoring by grouping, make sure we're on the same page. Okay. Let's look at part B. Work on the part B for just a second. See if you can factor that one by grouping. And then we'll go on to some new stuff. While you're working on that one, I'm going to pass out the new notes here. Yeah, I'll be right there. Yep, so if you pull out the negative, so take a negative sign out of each of them, so you're going to be left with it there. Yep, yes, negative one, that's right. Yep. So we change that book. Yeah, there you go. Yep, you have a lot of negative ones. Ready to chat? Yeah? Okay. So you're looking at part B here. Factoring by grouping. Looking at the first two terms grouped together, what can you factor out? A 2x. Good. Everybody agree that there's a 2x that you can pull out? Yeah? Okay. After you pull out the 2x, what are you left with? X minus 2q. Good. So we're pulling out the 2. So the 2 is completely pulled out, leaves a 1. There's 2 x's. We're pulling out 1, so it leaves 1. Right? So since I've got, and then the second one we pulled out a 2, it leaves the 2. We pulled out the x, so it's gone. It's in front, right? And we won't do anything with the q, so it stays there. So what are we looking for, hopefully, in the second piece? The same thing, the x minus 2q, right? What do you pull out of the second one? 3y, and you get x minus 2q. Otherwise, it would be a really bad example to go through. Okay? Now, what do both chunks have in common? The x minus 2q. We pull that whole chunk out. What are we left with? 2 plus x plus 3y. Good. So we're taking that whole thing out. That okay? Again, I'll leave the rest of these for practice so that you have those on Moodle, but I want to go on to the new stuff today as well. The answers are on Moodle. But let's see if we can go through some new stuff. Now, again, the whole idea for why we're doing all of this, other than the fact that it's fun, is all get out, right? Everybody loves doing this stuff, yeah? No? Maybe just me? Okay. Anyway, the whole point of doing this is you're trying to break down more complicated things into simpler pieces. That's the whole reason why we're doing factoring. And like I mentioned the other day, factoring never goes away. Okay? You have to know how to factor. Oh, that was a good drop there. It went all the way across.
Yeah, I know.
Yeah. Factoring never goes away. We're going to see factoring over and over and over again, not only in this class, but any math class past this one, you have to know how to factor. Never ever goes away. So that's why we're spending time on it, why I'm harping on it, because it's just something that you have to do over and over and over again to be able to solve math problems. Okay. And again, the whole idea behind factoring is kind of like what you do, anything that is hard to do, you want to try to break it up into more manageable pieces, right? Anything that you ever try to do in life that's really hard to do, you want to try to break it up into smaller pieces and do the smaller pieces over, and you try to get all those pieces to work together, and then the harder thing's done. Okay? Same kind of concept here for factoring. We're trying to break it into smaller pieces. All right. So, what we're going to start talking about today is factoring what we refer to as trinomials. Okay? Trinomial is just a special name for a polynomial with 3 terms. That's what the tri is. Okay? The trinomial just means it has 3 terms in it. And we're going to deal with ones today that have what we refer to as a leading coefficient of 1. So just to remind, remember the highest degree term is your leading term, and the coefficient on that one is called your leading coefficient. Okay? So when we mean a leading coefficient of 1, if we look at this example with the x squared plus 6x plus 8, the x squared is the highest power term we see. The coefficient on that x squared is 1. So that's what we mean by a leading coefficient of 1. Okay? Leading coefficients and leading terms are important later on in mathematics to be able to do some, what we refer to as analysis types of things, trying to figure out what goes on with certain polynomials from a graphical perspective is one use for it. Okay? So that's one of the reasons why we have these special names for those things. That leading term, that highest powered term, is what we're going to be interested in later on for those kind of things. Not this semester necessarily, but that's why we give them special names. All right. In any event, pardon me. When we have these types of trinomials, we're going to try to factor it a particular way. And before we try to do this example, let me just write something down the other way. Let's do a multiplication, okay? So if you had something like x minus 1 times x plus 6 to start with, and we just wanted to multiply that, okay? Notice I've got two two-termed polynomials, call those binomials, because there's two terms. I've got two binomials where both of them have an x to start with, right? Let's see what we end up with when we multiply these things together, okay? So again, when we multiply, remember we have to do all the distributions, right? We have to do x times x gives us x squared. X times 6 gives us 6x. Negative 1 times x gives us minus x. Negative 1 times 6 gives us negative 6. And do we see anything that we can combine? Yeah, the 6x and the minus x, right? What does that combine to? 5x. Good. All right. So, again, we did the multiplication. Our goal here is to be able to do this backward, right? But let's see what happened with the multiplication. Notice again, we started with two binomials. Both of them just had an x to start with, right? The x times the x gave us this x squared. That's that leading coefficient of 1 on the x squared, right? And 1x times 1x gave us 1x squared. Now notice when we combine the two terms in the middle, that collapsed these two and made a single middle term. We've got this trinomial. So this is exactly what we're going to do. We're just going to do it backward, okay? We're going to start with this and try to break it up like this, okay? That's our goal. Start with the end and try to get back to the beginning, okay? All right, so let's look at the example that's here. We've got x squared plus 6x plus 8 is the end. Now notice when we multiply these two things together, notice the number on the end here, the minus 6, was the product of the minus 1 and the plus 6, right? Okay, so this 8 on the end is going to have to be the product of two things. There's going to be the constant that's on the end. We're going to figure out how to break that apart. Well, there's really only two ways to break apart 8, right? 1 times 8, 2 times 4. Agree with that? Okay? So this is the process that we're going to start with, is trying to break apart that constant, the 1 times the 8 and the 2 times the 4. Let's look where this middle term came in, the plus 5. Where did it come from? Adding that number and that number, essentially, right? Because we had the 6 got multiplied by that x, the negative 1 got multiplied by that x, and we added, right? So this number in the middle has to be the sum of the two things that multiply together to give you the last number. Okay? So we look at the 1 and the 8, added together gives me 9. The 2 and the 4 added together gives me 6. So do you think we want to use the 1 and the 8 or the 2 and the 4 based on what's here? The 2 and the 4, right? So that's exactly how that tells us how it breaks apart. So the x times the x gives you the x squared. The 2 times the 4 gives you the 8. And when you add the 2 and the 4 together, you get the 6 that you want. Okay. All right, so let's see if we can do this with the next example. We're going to start with the x squared minus 2x minus the 15. Okay. This one's a little bit trickier because it's got the minus sign in it, but we're going to attack it the same way. Let's ignore the negative sign to start with. What things multiply together to give you 15? You get 3 and 5 and 1 and 15, right? That's it, right? So for 15, we have 1 and 15 or 3 and 5. Okay. And that's it. That's all it can be, right? For multiplying. But notice that we have to end up with a minus 15, right? In order to be a minus 15 when I multiply, 1 has to be positive, 1 has to be negative, right? but I don't know to start with which one's which. Okay, so that's why we've got 4 lines here. So we could do -1 times +15. We could do 1 times -15. We could do -3 times 5, or we could do 3 times -5. Okay. These are the only 4 ways that we can multiply together and get the -15. Can't use integers, but these are the only 4 ways we have to multiply together to give us -15, right? The only way to get 15 is 1 and 15 or 3 and 5. One has to be positive, one has to be negative. That's why we got the 4 ways we can do it. That make sense? Now what happens when we add the factors together? When I do -1 plus 15, what do we get? 14. When we do 1 plus -15, we get -14. -3 plus 5 gives us 2. 3 plus -5 gives us -2. Which of those cases do we want? Yeah, the last one, right? Because look, that's the middle term, isn't it? The -2x. So this is the one that we want. We want to use the +3 and the -5. Okay? Now let's look at what that means for our factors. Up here, we had +2. The factor was x plus 2. We had +4. The factor was x plus 4. So what do you think the 2 factors are going to be for this one? We've got +3, so the factor will be x plus 3. We've got -5, so the factor will be x minus 5. Good. So far, so good? Or so far, so bad because you hate it? It's okay too. You can hate it, we still have to do it. Okay. All right. Let's look at the next one. Let's look at these examples here, see if we can figure it out. All right. First thing I want to look at, factors of that number. Okay. So what things multiply together to give you 12? 6 and 2 works. 3 and 4 works. 1 and 12 works. Good. That's it, right? And again, if you need to use your calculator to figure out what divides, that's fine. Now I got to figure out which ones I need. Well, notice it's a plus 12, right? So that simplifies a little bit of things a little bit, right? I think it's a plus 12 there. I want things that multiply to 12 and add to what? 8. Of these 3 choices, which one adds to 8? The 6 and the 2, right? So this one right here is what we want. Okay? +6 and +2, we get x plus 2 and x plus 6. And you can write it the other way too. If you write it as x plus 6 times x plus 2, that's the same thing. And remember, one of the nicest things about doing factoring problems is that you can always, always, always check your answers. Multiply it back out, see if you get the same thing that you started with. That's one of the nicer things about being able to do factoring is I can always check my answer just by remultiplying it out and see if I got the right thing. It's okay? Next one looks like the previous example that we did, that x squared minus 3x minus 18. First thing we need to do is what? What do we need to find? Yeah, factors of 18, right? So if I look at my 8, I'm going to look at this one first, the 18. What things multiply together to give you 18? 6 and 3 work. 9 and 2 works. 1 and 18 works. And that's about it, right? Because 4 doesn't divide, 5 doesn't divide, and we already had 3 and 6, right? If you don't see it right away, 1 and the number always works, right? Start with 2, see if 2 goes into it. Then do 3, then do 4, then do 5, keep going. Eventually, you'll get to about halfway, and like, oh, hey, look, they're starting to pair up now, I'm done. Okay? You can get them that way. So calculator always works out really nicely. All right. So far, so good. Yeah, we're okay with that. Now, the next thing we look at is this. It's negative, right? So that tells me that one of them has to be negative and one has to be positive, right? In order to get a negative when we multiply, one has to be positive, one has to be negative. Don't have any choice. Okay? So which one's going to work? Well, this is calculator kind of active idea, right? Put in, I'm going to start at the bottom because I know it doesn't work. Negative 1 plus 18 would give me 17. 1 plus negative 18 gives me negative 17. Those don't work, right? Negative 9 plus 2 would be negative 7. 9 plus negative 2 would be positive 7. That doesn't work. 6 minus 3 doesn't work, but negative 6 plus 3 does, doesn't it? Okay. So what we want to use here, we want negative 6 and positive 3 work, right? So if those are the numbers we want, what are the factors going to be? And x minus 6 and x plus 3. Does that make sense? Okay. All right. So notice, let's look at these two before we do the last one. Okay. Look at these two here. Notice that we had plus 12, plus 8, both were positive, right? We had minus 18, so one of them was positive and one was negative. Look at this last one now. I need plus 20 when I'm done. So first thing we want to do is find factors of 20. What works for 20? Yeah. So usually what I do is I do 1 and 20 to start with and just start going up on 1 and the other one will go down. So 1 and 20, 2 and 10. Does 3 work? Nope. 4 and 5. And now I know I'm done because the next number I would check is 5. And I already wrote down a 5. Right? So I'm done. Okay. Now notice that when I multiply these together, I have to get a positive 20. But when I add them, I have to get a negative 9. So what's going to have to be on both of the numbers in order to multiply and be positive, but add and be negative? They both have to be negative, right? So these two things together, this plus sign here, along with this minus sign here, tells me that both factors have to be negative. Okay. So which of those are you going to use then? 4 and 5 add to 9, and they both need to be negative, right? So we'll do negative 4 and negative 5. So now what do we get for our factors? X minus 4 and x minus 5. Good. All right. So far, so good? Okay. The reason why I'm harping on this again is because we're going to make it a little bit more complicated in the next section on Monday. So we'll make sure that we're all on the same page with this one. All right. This is just saying that we start to add in new old techniques with new ones. So this statement in this particular part of the notes is just saying that the very, very, very first thing you should always look for anytime you're factoring is a common factor. Okay? That should be step 1 every single time. Step 1 is see if there's a GCF. That's always step 1. Okay? So let's see about a couple of examples. These are on the back side. First, look for a GCF, then try to factor. So let's look at number 1 here. Do you see a GCF? Do you see something that's common to all 3 terms? 3, right? So that's first things first, factor out of 3. What are we left with when you factor out of 3? Good. X squared plus 10x plus 21. Now notice, if I ignore the 3, this looks like a problem that we were just doing, right? This is a trinomial with a leading coefficient of 1. So if I just want to factor this, what do we do first? Factor the 21, right? For 21, what are your possible factors? Well, I have 1 and 21. Yeah, so 3 and 7. And if 2 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, and you've already had 7, right? So that's it. Okay. This plus sign right here tells you that both of the signs have to be the same, right? Either they're both positive or both negative. Which is it in this case? Are they both positive or both negative? What tells you that? That one, right? It's a plus 10. So when you add together, they have to be positive. So they both have to be positive. So what are we going to use then if they're going to both be positive? Yeah, the 3 and the 7, right? So what do you get? Good. Yeah, x plus 3 and the x plus 7. The x plus 3 and the x plus 7 correspond to the x squared plus 10x plus 21. We still have the 3 out in front, right? So it still keeps going. And don't forget to write the 3 too as part of the factoring. Yeah. See if you can do number 2, and then we'll chat about it. While you're doing that, let me hand out some more practice. Yes.
Last one. I factored this out and I got so what did I do?
Let's see, you got 3x cubed, and you pulled out the 3x, and you got x squared minus 8x, and then plus 9. So what that tells us in this case is that it does not factor. Oh, that tells us, yeah.
Oh, okay.
So, yeah, it just tells us that it doesn't factor. You're just done with that particular one.
All right.
Yep. Sure.
Are we doing the last one?
You can do it. Yeah, go ahead and try the last one too. That's fine. Ready to chat about this one? Or are we still working? Or are we being quiet? Let's see if we can go over these two here for the end of the class. All right, so let's look at number 2 here. What did you factor out of number 2 to start with? A 2? And y, right? Because there's a y in every single term as well. Certainly 2 goes into each of the coefficients, and there's a y in every single term, right? What are we left with after you factor out the 2y? And then a minus 10. Good. Yeah. That part okay? Okay. All right, so now let's look at the trinomial that we have. What's the first thing we look at? Factors of 10. Good. What things multiply together to give you 10? Yeah, 5 and 2 and 1 and 10, right? We agree? That's it, is all we have, right? Okay. Now, looking at this, what does that tell you? What does the negative tell you? Good. One of them has to be a negative. That's what that negative sign tells you, is that one of them has to be negative, one of them has to be positive. So basically, you're subtracting the 2 to figure out what the middle number is, right? All right, so to get a positive 3, what do we need to do? So yeah, so we know that, but one of them, you're right. One of them has to be negative, one has to be positive, right? Okay. So do I want to use the 1 and the 10 or the 5 and the 2 to get a positive 3? The 5 and 2, which one has to be negative? The 2 does, right? I got to do a 5 minus a 2 to get a positive 3, right? So I want 5 and negative 2 are what we want, right? Agree? Okay. So what are we left with then? Good. Yeah. And don't forget your 2y still hanging out in front there, right? Okay. Let's do this last one, and then we'll go. How's that sound? Everybody's anxious to leave today. Is there something I said? I gotta go. I've had enough. All right, first thing here we have what? What do we look for first? In every single factoring problem, we should always look for a greatest common factor, GCF. Great. What's the GCF here? 3x, right? 3 goes into every single one of them, and there is an x in every single one of them, right? We're left with good. X squared minus 8x plus 9. Everybody okay with that for factoring out the GCF? All right, so now if we're trying to factor this part, what do we find first? Factors of 9, right? What are your factors of 9? 1 and 9 or 3 and 3, that's it, right? We agree? What does this tell you? This is a plus 9. They both have to be the same, right? They're either both positive or both negative, right? This tells you that they are both negative. Does negative 1 and a minus 9 work? Does that give you negative 8? Does negative 1 and negative 9 give you negative 8? That one doesn't work, does it? Does negative 3 and negative 3 make a negative 8? No. So does anything work? No. So this is it. That's all the farther you can go. Okay. This is it. You can't go any farther than that. Okay. That's it. That's all you can do. So we refer to if you've got a trinomial that you cannot factor, we call it irreducible. I don't care if you really remember the word. This is the word for it. Okay. If it cannot be factored, you call it irreducible. You're trying to reduce it into pieces. So if it can't be factored, it's irreducible. Like I said, I don't care if you remember that name or not. All right. So you've got some extra practice problems to work on. Work on those for next time, that extra sheet that I just gave you. Okay. Work on those for next time. We'll do a few of those before we start the new stuff on for Monday, whatever day that is. All right. Have a good one. We'll see you on Monday then.
So for that, yeah, the answer for the 3.
Mm-hmm.
What was the word again?
It was irreducible, but that part, just for the other one part, is irreducible than what we use. But for the final answer, you would just leave it. Like what I underlined.
Extra R with
No. Yeah, is that last line that we wrote there? We're done. That's all we have to do. You're welcome. Yeah.
Should be easy. I finished practice problems, but I see it.
So we're gonna have the square down. That's the last part. So what's 5 times 2? Yeah, that's good. Yeah, you were close. Yep.